exploring the underside of Greenland's glaciers in a first by robotic submarine. This is what I was talking about with my eldest grandson yesterday. We watched some videos on this, how far a submarine can go. Well, at 1,000 meters, it's about 100 atmospheres pressure. And the submarines that can go the furthest down are basically those round spherical scientific submarines, and they have claws on the outside that can bring up samples in their baskets. Now, an upcoming robotic dive to the underside of Greenland's glaciers may reveal how much these rivers of ice will contribute to sea level rise. Let's remember that the west side of Greenland has volcanoes under it, and it is melting there. And we have a lot of heat coming from the Arctic under that area of, and we'll go to null school, see the temperatures around Greenland as well. Because even now we have the northern hemisphere has winter. I want to see what is going on there as far as the water temperatures. And we'll see that in just a few minutes. Now, the mission scheduled for midsummer 2023 will send a robotic submarine to the bottom of the outlets of 3 glaciers, the Kangiliup Sermia, Umiamaku Sermiat, and Kangerlusup Sermia. All 3 are on Greenland's west coast, though. And just like all glaciers, these swaths of ice flow in particular, they move ice from Greenland's interior to the ocean, making their dynamics important for understanding sea level rise as the Arctic melts. This is the first time scientists will have a close-up view under the large island's glaciers. The big uncertainty in Greenland's contribution to sea level rise is how fast the ice sheet of Greenland is going to lose mass. This is what Ginny Catania, professor at University of Texas Jackson School of Geoscience, who is leading the voyage, said in her statement. And she says, "We know how much sea level is stored in the ice sheet. We know climate is warming and changing the ice sheet, but what we don't know is the rate at which these glaciers will contribute to sea level rise." To find out, Catania and her colleagues will deploy a remotely operated submarine named Nereid under the ice, NUI, to the underside of the glaciers where they reach the ocean. NUI will focus not on the ice itself, but on the walls of sand and sediment that the glacier pushes out ahead of itself as it flows out. These earthen barriers are known as moraines, and they help stabilize the ice like a plug, keeping water from flowing down the drain. The question is, if the plug is pulled, what happens then? The sub will map the topography of the moraines and take sediment cores, which will help researchers better understand how stable the moraines are. The submarine will also collect sediment samples from the sediment plume that flows out under the glacial ice. Some scientists have suggested that effects of global warming on sea level could be delayed if some method was used to build up these submarine moraines, propping up the Greenland ice sheet. The research will help inform whether their idea has any merit, according to University of Texas at Austin. This is high risk, high reward science, but it's exactly the kind of bold step needed to tackle the pressing and societal relevant questions about climate change and geohazards. This is what Damian Stauffer, director at University of Texas Institute for Geophysics, one of the co-partners in research, said. He says if it succeeds, it could transform our understanding of sea level rise. Now, operating under the harsh conditions along the Greenland coast is no easy matter. NUI will be connected to a research vessel with a thin fiber optic cable 10 miles long. If the cable snaps, the sub can pilot itself back to the surface using acoustics and is programmed to return to a pre-programmed pickup location if communication falls. I believe they didn't say this is a manned sub. I believe it is an unmanned sub, okay, because it didn't say it was manned. Now let's go to null school to see what the temperatures are around Greenland real time. I only support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. So here we are at null school. This is the equator. This is North America, as you can see, the Great Lakes. And here we have basically showing chemical, SO2. Okay. Let's go to the air. Air. Okay, this is Greenland right there. You can see the currents, the air currents. Let's go to the ocean. Ocean currents. And let's go to air. I want to go to temperatures. Wait a minute. Air temperatures. Okay. Okay, that's cold there. This is nice and warm here. Okay, you can see the flow of the basically the Gulf Stream bringing up the warm air towards England. You can see that. And let's go to ocean temperatures. Air temperature, ocean. It's not giving us the ocean temperature, but anyway, that's okay. Air temperatures. Air temperatures. That's the wind temperatures. Air temperatures. Okay. Air temperatures. This is the Mediterranean, as you can see here. We're very warm weather. I'm sitting here, right there. That's me right there. My sister's sitting all the way over here. Let me see. She's in Harleysville, Pennsylvania. Right there. Okay. Somewhere, where are we? Pennsylvania. Right there. Somewhere around there. So, okay. Okay, so it's pretty cold, as we can see there. Let's go to our ocean. Currents. Ocean currents. Okay. Waves. Wind. Okay. This is where we have the, it's not showing us, I want to go to the, now, of course it's now. Okay. Okay. Let's go ocean currents. Look at this here. Okay. Waves. And this is the Gulf Stream. You can see this going that way towards giving the wind and temperatures. Okay, there you go. Wind and temperatures. The beautiful Gulf Stream giving warm weather towards Europe. Okay, so, okay, that's normal. You can see, of course, this area here is a lot warmer than this area here. This is the area of the volcanoes under the ice sheets of Greenland, right there. Particulates, should we go particulates? Wow, okay. It looks like that's Sahara sand. You see the Sahara sand, bringing it this way towards, some of this eventually comes into the United States as well, but it also goes this way because it goes up towards the north because of the wind currents. Okay, let's see what's happening in Tonga. Tonga, where's Australia? Just since we're here. Okay. Okay, Tonga is somewhere around here, between Fiji and North Island, New Zealand. Air temperature. Air chemistry. And SO2. That's Fiji right there. Okay, Australia. And this is where we had the earthquake, Johannesburg, yesterday. This is the East African Rift Valley, Great Rift Valley. And we had the Cairo earthquake yesterday here, 4.3. We recently had the earthquakes in Israel as well. Look at all that. SO2. Okay, so as you can see, okay, we didn't see much, but this is, okay, that's Iceland, which is, of course, a volcanic plume. Air temperatures. So, okay, this is, as we said before, warmer than the west because there's volcanoes here. And they're finding new ones all the time. Okay, so volcanoes are under Greenland, and volcanoes, over 147 volcanoes in Antarctica. Especially on the west, as you can see, that's warmer than the east. Okay. So leave your comments, and thank you for your support. Thank you very much.